Hi everyone, hope everyone had a cup of beer or so. Unfortunately, I don't have фирмовую кошулю, only regular one. However, I guess that this framework, Micronaut, was, I guess, author is exactly the author of Gradle. So maybe we have some colleagues with the previous speaker. My name is Dmytro. I work as a software engineer. About 7 years, mostly it's Java. Yeah, I saw a lot of shit. But what happens? Experience is experience. Today I would like to talk about the Micronaut and what's the framework, what new it supplies, what happens there, etc., etc. But let's ask first, who is using the Spring on the regular basis? Okay, great. Who is using Quarkus on the regular basis? Oh, cool. Who is used Micronaut or used somewhere? Okay, fine. Yeah, so Spring guys, it's great. A lot of familiar. I would characterize Micronaut as Spring-alike framework because a lot of experience that people was able to absorb and gather during the development was implemented in this framework. And to my mind, it's good because a lot of things you can apply here with a quick migration, etc. And Micronaut is actually providing a lot of cool things for the migration from the Spring. However, I guess enough for the prelude. Let's move to the next. In a nutshell, Micronaut is just a framework of Java. What framework of Java means? It provides dependency injection, support of web. It gives some opportunities to implement your business logic, somehow separate infrastructure code from the business logic, etc., etc. But what the key features of Micronaut is that Micronaut doesn't use reflection, doesn't use proxies, it doesn't use any caches to store everything of the reflection information. It's everything that you can move from the runtime to the compilation. We move from runtime to compilation. So this is a key feature. However, there are a lot of benefits of Micronaut. But in the list, and actually this list is followed from the documentation, there is missing one, to my mind, very major item is that Micronaut is good at the annotation processing. And I will show you, present why it matters and why it's cool. Because if we take a look at how annotation process works on the Spring, it's total hell. It's just reflections, it's dynamic, it's class loading, etc. It's not really good for the runtime and for the memory consumption. However, this one, I guess, is done very great. When you think about the Spring, you think, okay, this is dependency injection framework. We can just run Spring Boot, run new, and then do whatever we want. Make a configuration, provide beans. So quite easy one. But, you know, when context is up, when you have microservice, which, I don't know, start off with 3 minutes or so, then something fails. And you're like, gosh, why it happens? What was done? And you go fix something, again run, and again fails, etc., etc. It could be anything like ambiguous, exception, something else. And you kind of try to observe this long list of exceptions in the stack tray. So it's kind of really inconvenient. So Micronaut doesn't, as I mentioned, doesn't use any proxies. So you won't see any proxies or some class loaders in your stack. You just see your error, what it means, how it even can be fixed. So a lot of benefits to my mind that Micronaut provides. Let's take a look a bit in a close. Let's make a lean startup of payment providers, right? We're going to implement some small applications, and based on some conditions, we're going to make payment or no. Spoiler, we will make always payment because we're in startup. And what we're going to do, here we have decision service. Let me increase it. We have decision service, quite simple one. It only returns true. And based on the decision service, we try to understand whether user can pay something or no, right? Typical scenario, we do injection through the constructor and then use this decision based on some business logic, okay? However, comparing to the Spring, Micronaut doesn't provide any stereotypes with component, service, or repository. And one of the trickiest things about the Micronaut is that it doesn't provide any custom annotation. So mostly it's implemented GSR specifications. And from the special Jakarta package. So let's make our component, and as a component, it's singleton, right? So we say this is a component with lifecycle singleton. And of course, we need to add our payment provider as well to the context, as well to the singleton. So right now we're able to do payment, okay? Let's go to the test. Here, payment service should allow. Let's make some asserts, very stupid assert, payment service, pay. And we expect that it's gonna be as true, right? Because we did injection and everything fine. Yeah, so it's fine, test is fine, everything is good. However, yeah, necessary to mention that Micronaut as well allows you to inject your dependencies in a lot of containers. For example, it could be optional map, list, maybe some of you who wanted to outwire list of dependencies of some interface was able to place all this implementation to the list. So Spring gives an opportunity to such injections of a list of implementations. However, there are much better and much more container types that Micronaut supports, and for some reason they decided to rely a lot of business logic, a lot of infrastructure logic to these container types. I will show you more about how it works with life cycles. However, we can easily do the next. Let's, for example, we don't know whether this dependency is present or no. So what we can do, we can make this as an optional, right? As an optional, change it as an optional. Oops, sorry. Change to the optional. Okay, refactor, no problem. We do map, decision service, decide, or else false, right? Or else false. And we're gonna to run it. And as well, fine. So dependency we have. It was able to inject, so no problem. So this how we can make wrappers on our dependencies. However, funny story happens when we have multiple dependencies, right? It's not a problem, basically, to have only one interface and one implementation. Oh, by the way, raise hands. Who use one implementation and one interface? Who is doing that? Come on, rise. Don't hesitate. Everyone is doing it, I know. Yeah, I saw a very funny thread about it. Everybody told no, but I everywhere saw that it was. And I don't know where these people work that say no. I didn't work with them for some reason, but yeah. So yeah, and here happens a problem when you have one interface and multiple implementation. And that's where a lot of decisions should be made, right? Because apparently that ideally we should be kind of on a level of abstractions, trying to resolve it somehow without concrete types. But if you remember, for example, in Spring aliases, we had a lot of alias hell when you can call this name, then this name, and you override it. So that's really bad practice, honestly, rely on the names when you inject dependencies. However, let's take a look at that example. We have payment repository, okay? Payment repository, and the payment repository implements two classes, which is MySQL payment repository and Postgres. This PostgreSQL payment repository. Everything is quite simple. So what we're gonna do, we want to make like this: private final payment repository, add it to the constructor, no problem. Return payment repository, save. And something we're gonna to save, right? Go to the payment service. Let's go here. Assertions, assert true. Payment. Oh, sorry, it was a caps lock. Save. And what we're gonna to have, I guess you already knows, is gonna be an error. That's an error because it's ambiguous, right? We don't know what the candidate we need to use. So what we can do, and what basically a lot of Java developers do, qualifier. Qualifier is resolution for everything. Qualify entire your code base. And basically we can do this here as well, but we don't have clarify here. We have named. And what we want to do, I want to inject MySQL. Okay, let's take a look. And true, yeah, fine. Yeah, you see, hi from MySQL, test is passed, no problem. The thing is, name is not really case sensitive. How it works, it gets the value from the your string parameter and appends to the name of your service. Of course, PostgreSQL, let's be like that. Maybe I made some typo, but okay, you just believe me. Postgre, yeah, like that, I guess. So let's be like that. Never mind. But the thing is, it's not really construct aware, right? We don't know actually. We don't know what the name it could be, right? We don't know what the name it could be, for example, when it could be renamed or maybe changed, because strings, it's immutable, but people change it quite often, believe me. So it's better to come up with some construct aware. And how construct aware could work, basically you can rely on the annotations. Annotations is really a great way how you can make your contracts, how you can come up with your identification that this object is going to be injected with this way, this object going to be injected with this way. So how it works, if not to be, let's go here, MySQL, okay. We did annotation, no problem. Retention, going to runtime. Here we're going to add qualifier. Go to the payment service and say, I want to have MySQL. And this is dependency of your library. For example, you have a library, and this library is utilized by multiple services. You don't need to provide anymore any names. You can provide annotations for the proper injections. So let's do that. It's fine. Yeah, it works fine. You can provide as well PostgreSQL. We have PostgreSQL annotation. Let's do that. Let's go to the payment. Yep. Okay, Postgres just, yeah, because it returns false, it's fine. So annotation aware is great substitution for the strings. But the thing is, as I mentioned, it's better when we think about the maybe higher level abstractions, right? Because we don't want to substitute this name every time. Because when you need to change property, then you need to change somewhere implementation, injections, it's not really convenient. So instead, we can make kind of configurable injections. Configurable injections rely on the parameters that you pass to your dependency. Let's say we go to our MySQL payment repository, okay, and we have so fancy annotation, which is called configurable payment repository. And you can take a look here that environment here is dev, and the property, we have their environment, so default is going to be environment. And let's go to the MySQL. Here we're going to type configurable payment repository. It's going to be default for the dev purposes. But for Postgres, it could be like what we have, prod, okay? So what we're going to do, go to the payment back again and say, okay, I want to inject something, default, okay? Okay, hi from MySQL, again, it's default one. You can run your application based on properties or so, it's going to be used the MySQL. Then for some configuration, you're going to use what? Production. You run it, it will fail, don't worry, because Postgres returns false, but yeah, it returns you PostgreSQL. Quite great approach to my mind, how we can avoid a lot of, how we can at least avoid strings, which quite not really clear for the development and provides only messy API. But of course you can ask that, do we have any other options? Yeah, we have. Nobody really removed the prioritization. To my mind, prioritization in the frameworks is quite strange, but still. We can say that this MySQL could be a kind of primary or so, right? So we can say this is primary, and the Postgre is secondary. So this way we're going to use MySQL on the constant basis. But for some reason, somehow, Micronaut developers found, I don't know, some naughty developers, and they was able to read their minds and implemented one interesting annotation that I guess everyone subconsciously wanted to use, especially when you want to do everything just to run your project. What the annotation is, you can ask me. Let's go to the back again to the MySQL. Let's remove. Okay, we're going to have ambiguous exception because we have two dependencies. What we go here, and this is magic. I mean, I don't know where they're applicable on the production, but let it be any. You can inject any. So, like, hi from MySQL. Okay, run back again. It's failed, hi from PostgreSQL. It's just like, I don't know who did it, but it sounds really funny. Maybe it could be really useful for the tests or so, but this any just game changer. I guess here is day of game changers. Yeah, so it's quite interesting approach how we can cope with your multiple implementations. So yeah, any is a good one. Another quite interesting topic is about how you can improve your contract awareness. Back again. The thing is, it's not really good when you inject concrete types, right? So everyone can return concrete, everyone can specify concrete types, and nobody can actually forbid you to doing that on the Springs. So you can do like here, MySQL payment repository, and then don't even care why it's like that. Nobody, just ship it and that's all. But the problem here that on the top level, if for example you have library again or so, you can see bin, and you want to make it typed by some other, by your interface. This way Micronaut disallow you to inject concrete type of this implementation. You still is able to inject MySQL, that's not a problem. However, only with the abstraction. So if we go back to the payment repository, put here payment, here use MySQL, no problem. You're going to use MySQL, and that's no, yeah, so without any issues. It's a good one. I guess it's really great idea, and I would use it if I had such opportunity in the Spring. About scopes, I guess everyone. Okay, let's say who is using prototype? Who is using prototype on the project? Yeah, it's like not. Basically, we cache, right? We cache dependencies. We use singletons and don't really care how. And if you want in Spring use prototypes, it's honestly a bit messy because you have to provide lookup method. Lookup method is this annotation lookup, some dummy method that returns nothing or unsupported, and Spring somehow determinist. We don't have here. Micronaut doesn't provide any lookups, no any other, or if you remember XML, of course, XML lookup method, it's something. Instead, you can do like that. As I mentioned before, it's really important to have and utilize here container types. Such container types is called bin provider. Bin provider is wrapper on your object, and this is with this interface you are able to detect the lifecycle of your bin and create it once again or reflect the lifecycle. Let's like do like that. Just a second. Here bin. Let it be as a prototype. Okay, because for now it's singleton. Nothing interesting. If we don't use the bin provider, it's always going to be singleton. However, I want to mention that by default in Micronaut, scope is prototype. It's not a singleton. It's one of the interesting specifications. But still, yeah. If we go here, we want to change to the bin provider. Okay, everything is fine. It's MySQL. It's okay. And I want to call here method get. But just to check that it's true, we're going to log 2 times. This is hash code. It should be different. So we're going to see 2 different numbers. So, and we have 2 different numbers. So this is how they reflect this life cycles. But comparing again to the Spring, Micronaut provides you much more scopes out of the box. For example, context, infrastructure, thread local. To the most favorite is actually thread local. I can tell you why. Some applications are written like that. We have some context. This context is wrapped by thread local of some context. Then something happens like process, and we try to mutate or do something with this context, and then what happens, you just close this context and like pass in all your global variable of context through all the life cycle. And we are used to produce a lot of factories, a lot of wrappers for that, etc., etc. Do it. You just can use thread local. You don't need to provide any wrappers. To my mind, it's really useful. Other ones like refreshable is for the serverless. So if you have some kind of application that works on your AWS or Google Cloud or Azure, so I guess this scope was provided basically for that purposes. Yeah, default scope is prototype, and as I mentioned about annotation processing, as you can see here, foo, we have annotation driver is here, and if we annotate this foo with annotation driver, it has singleton scope, and if you try to override this prototype, it won't work. It won't work because you are not allowed to rewrite the scopes. So that's why singleton is happy sun, but driver is set cloud. Instead, if you want to make your API extendable, for example, you want to specify the default scope, you can use annotation default scope and mutate it wherever you want. So here is like no problem with that. Another cool thing and problem that occurs during the development is how we can add to our context some beans or dependencies that are out of our application. For example, libraries. So I don't know, some other dependencies. We used to use configurable classes, and Micronaut has factories. Bean factory is a quite simple class with annotated factory. And inside this factory, we're able to make instantiations of our objects with the constructor new. So, but what's more interesting here is that we're able to even specify beans of primitives. It could be primitives like long, double, short, or other primitives that could be asked on the interviews. And as well, could be here arrays. So it's that's how you can specify beans, for example, of your configurable properties. So how we can do that? We want to our MySQL repository, for example, inject, I don't know, number of threads or number of something, of connections. What we can do, we go to our factory, we create our instance, nothing special here. We have prototype, it's okay. We're going to create constructor, connection, let's be like here, private final connection size. Okay, this connection size is connection size. And yeah, let's log it. I hope everything will work fine. It should be. Yeah, multiple, of course, it's fine. Because we already added to the context. Yeah, fine. So we're able to inject this some number of connections with the primitives, the beans. Ideally, in documentation, it's mentioned that it's worth using only one approach. However, nobody really follows the documentation, and you can mix them together. I don't think there's going to be a lot of problems, honestly, but I guess Micronaut will notify you that something is wrong, you cannot do this or that, but to my mind, it's quite useful in a lot of cases, and bean factories is really great, and I actually would use them even more than annotations. But it's up to you. Still, it's a lot of features here, and bean factories is actually very necessary when you want to specify exactly your life cycle of objects. So you have more control on how your object behaves. You kind of make specifying custom life cycles within the factories, and it has a lot of rich functionalities that you can do for your object tracking, monitoring, AOP, etc. So everything happens on the bean factories. A lot of information about whether we need instantiate object or no. So for this purpose, we have conditional beans. I guess you're as well aware about how it works on the Spring Boot when we have conditional beans. Here, it's called requires. A lot of conditions here, like, yeah, actually, that's what I meant about the annotation processing. You can specify set rule of your conditions and use this set of conditions specifically for this kind of beans. For example, for the repositories or so. Quite good one. There are a lot of rules. Require the absence of one or more beans or not env. So like everything but not this env. Quite useful, I would say. It's really very rich functionality. Yeah, even actually some environments properties like SDK Java, what the version of it, etc. So it's quite cool. Yeah, rules can be combined. So as well, we have to take into account this one. And what's really cool here is that Micronaut gives you opportunity to make a bin replacement. Bin replacement is something that, I don't know why, but in Spring still absent. You're not able to replace some bin. You still need to extend and make alias for that, and then you can use. Sometimes it's really messy when you do tests, namely integration tests. And here you can do just substitute. And if you within, for example, some integration test, you can substitute it to the mock, and you don't have to somehow manage different contexts. So it's quite a good one to my mind. Yeah, bin life cycles, the same. Here, nothing new. We have post construct, pre-destroy, this everything the same. We don't need to provide anything. Only, of course, have to mention you're not able to call it on the primitives, of course. Yeah. Who would do that? I don't know. Yeah, and of course, one of the most important features here, to my mind, is that Micronaut doesn't provide any bin post processors. Oh my god! If you remember, you get object and you need to return object. By object, I mean type object. And when you get it, you can return different objects. It's like total nightmare, and you like do this like instance of I don't know who is using still bin post processors. I've never used them, honestly. And basically people do a lot of reflections there in this bin post processors. It's something that I don't understand still. Instead, Micronaut gives you a lot of context-driven development. Event-driven development by making the invoking specific event when this bin is created, and when this bin is created, you're able to get exactly this bin, return this bin, only modify it, and do a lot of stuff. So, and as well, in these listeners, you can specify your reflection. Of course, it's not reflection, it's called here introspection, your reflection logic, and somehow enrich or mutate or manage somehow this particular object. And this is what event listeners and events for. Yeah, I don't have right now, it's only left 2 minutes. Anyway, I want to present you how this introspection works, because it's really important in the Micronaut about the introspection. You have such listener, context load listener. So what it is, when bin is created, we emit event, and this listener consumes this event, and we can do something, right? So what we need to do here? Let's, for example, we want to have some unique identifier for our object, right? So kind of, as well, very simple scenario. We have private final UUID, okay? This is our field. This is our field. We get this one. We have some custom annotation, UUID generator. It's just a plain annotation without anything special, right? And we need to do the following. We need to here put my annotation introspected. Introspection reflections in the context of Micronauts, it's almost the same, but introspection is more about self-observability. Reflection is about the mutation, but it's only terms. It's still the sense. You can mutate your objects with the introspection, at least in Micronaut. We can keep it for the theoretical and other talks. And of course, introspection doesn't work like direct set accessible true, okay, let it be fine, and let it be other modifier, this I inject to the constructor, this I inject to the fields. Here it's quite everything is plain, because we need to or put with fields or by methods. So we need to have accessor for that, so we cannot avoid it. So as a result, what we have, we want to somehow have identifier for this payment service, only have UUID, and we would like to this UID show on our tests. So what we go here, let's do this. We say, okay, this is payment service. We want to introspect it, make self-observability, and from this object, we get the constructor and lists all the arguments in this constructor. As you know, we have this UUID generator annotation. And in case we have it, we need to do something. What we do, we, from the introspection, from this object, we get this field, this property, by its name. So we have kind of field property. It's called, just a second, UUID. Quite easy to remember. So this is string. And to this property, to this bin property, we set some random value. It's quite easy one. And again, it's not the reflection. So let's do this. Go to the service and let's get to UID. Assertions. Okay, not null. Payment service. Get to UID. Let's run it. Let's take a look. Okay, it's not null, but let me basically show it as well in the test to make system out. Why not? I don't have logger here. So here, we were able to inject it with introspection. Again, it's another way how we can inject our dependencies through the reflection or introspection. So yeah, that's all. This is my context. If somebody wants to join to the Twitter or LinkedIn, feel free. And yeah, any questions?
O, są pytanka.
Hi, since Micronaut doesn't use reflection at all, does it provide some types of compile time checks when compared to Spring?
Yeah, actually, everything, as I mentioned, checks on the compilation. And basically, if you even try to inject, I'm not aware about specific mechanism, how it calls, but it makes a lot of validation that you try to construct all of your dependencies in the it's called kind of semantic tree. And in case when you build this tree, it tries to compile it. And if error during the compilation occurs, it shows you. But for example, you want to inject some dependency that is not related that's not matched by type, or for example, you have some absent property. This is everything checks on during the compilation. During the compilation, not and during the runtime. So if you have concept fail fast, you can even have with Micronaut even faster fail, right? Because you're able to detect such uncertainties during the compilation. I don't know, maybe in Spring. No, in Spring actually you cannot do that. Only with the runtime. I don't know what's with Spring Native, but.
Thanks.
Okej, czy jakieś jeszcze pytanka? O, jest jeszcze z przodu.
Okay, so if Micronaut is not using proxy, so how to write transactional annotation in Spring Hour?
With introspection.
With introspection.
Introspection, only introspection. Introspection, that's your answer to any self-reflected logic. Everything, even AOP, and of course, yeah, the transaction is a part of AOP, any self-observability, any list, Jackson. If you want, for example, make a return, for example, you return JSON, right? We basically return an object and somehow it converts to the JSON. We use it for this Jackson. Jackson uses reflection, apparently. Here in the Micronaut, you are not able to return JSON if you not mark your object as introspected. This annotation, it's here, just a second. Yeah, this annotation introspected is your key to any self-reflected logic. If you want to convert from object to JSON, if you want to, I don't know, make some injections, if you want to make transactions, if you want to make any annotation processing with your custom logic, it's only through the introspections. You don't have, it allows you to, of course, use reflections. And in documentation, it follows that it uses as the last resort, but what's the last resort, it's not really actually mentioned. So only via introspection, you can do such scenarios. As well, yeah, AOP as well implemented with the help of introspection.
Okay, thanks.
Okej, dziękuję. Czy jeszcze jakieś pytanka? Dziękujemy.
Dziękuję bardzo.